Hello everyone, this is Arham from Sri Venkateswara College of Engineering, studying in second semester in the Department of Computer Science Cybersecurity. I am here with my subject Engineering Physics today to teach upon the topic optical fibers. Table of contents. What is optical fiber? They will be learning about its instruction, total internal reflection, angle of acceptance, types of optical fiber and its applications. What is optical fiber? An optical fiber is a cylindrical waveguide made of transparent dielectric material, glass or plastic, which guides light waves along its length by total internal reflection. Optical fiber is a technology associated with data transmission using light pulses traveling along with a long fiber, which is usually made out of plastic or glass. Metal wires are preferred for transmission, while communication optical fibers are also unaffected by electromagnetic interference. Construction of optical fiber. It consists of mainly three parts, that is core, cladding and buffer. It is also called as buffer protection or jacket protection. Core. Core is the inner part of the optical fiber. It is the medium which allows the light to pass through it. The core region has the highest refractive index, and in the optical fiber, the core is made up of glass or plastic. Cladding. Cladding is around the core. It has lower refractive index while compared to the core of the fiber. The cladding of optical fiber is made up of glass or plastic. The buffer is the moisture substance that is coated over the surface of the cladding. It is mainly used to provide flexibility to the optical fiber's core and cladding. The jacket is the outermost surface of the optical fiber that acts as a shield for protection for the inner part of the fiber. Total internal reflection, TIR. When a ray of light travels from a denser medium to a rarer medium and away from the normal, as the angle of incidence increases in the denser medium, the angle of refraction also increases for a particular angle of theta c. That is called as critical angle. I will be showing you the figure in the next slide. The refracted ray grazes on the surface separating the media, and the refraction will be equal to 90 degree. If the angle of incidence is further increased beyond critical angle, the light ray is reflected back to the same medium. This is called as total internal reflection. Total internal reflection, it has no loss of energy. The entire incident ray is reflected back. Here you can be seeing that the refracted ray is coming. As the refracted ray is shown, as the angle of incident increases, the refracted ray also increases. Here we have taken denser and rarer medium. First we show the refraction, then we show the critical angle and how it is equal to 1. Here we can see the equation, how it is written. That is n1 theta 1 is equal to n2 theta 2 for total internal reflection. Theta 1 is equal to theta c. So the final will be sine inverse will be equal to n2 by n1 theta c. Angle of acceptance in optical fibers. Angle of acceptance is defined as the maximum angle the light ray can have relative to the axis of the fiber and propagate through the fiber. Angle of acceptance and numerical aperture acceptance angle is the maximum angle of incidence with which the ray is sent to the fiber of the core, which allows. There are three types of optical fibers that we are learning in engineering physics. The first one is step index single mode fiber. Single mode fibers have a core material in the form of refractive index. The cladding material also has a uniform refractive index but a lesser value than that of core. Thus, the refractive index profile takes the shape of diameter, and the core is about 8 to 10 micrometer and the diameter of the cladding is about 60 to 70 micrometer. Because of the narrow core, it guides just a single mode as shown in the figure. Single mode fibers are extensively used and are less expensive. They need lasers as a source of light. Here you can see how the single mode index is there, and next two which we'll be learning are step index and gradient index. Next, we have step index multimode fiber. It is very much similar to that of single mode, but it has more than 2 to 3. The core diameter is bigger, 50 to 200 micrometer, and the cladding is about 100 to 250 outer diameter. The refractive index profile is similar to that of single mode, the larger plane region for the core. Due to the large core, diameter can transmit the number of modes of propagation. There is more than one mode, that's why it is multi-mode. The step index multimode fiber can accept either a laser or LED as source of light, at least expensive of all typical application data links, which has lower bandwidth requirement. Then we have multi-mode graded index. You can see there are a lot more propagations in a similar helical structure. It is also called as GRIN, G-R-I-N. The refractive index of the core decreases in radially outward direction for the axis and the fiber, and it becomes equal to that of cladding in the interference because the refractive index of the cladding remains uniform. Laser or LED is used as source of light in this expensive of all. It is used in telephone trunk between central offices so that there is no attenuation between them, that is disturbance. Applications of optical fiber. Single-mode fiber optics is used in communication and data transfer. Multi-mode fiber optics is used in data transfers in buildings and short distances. Plastic fiber optics makes pretty light displays. This is also used in the basis of lighting systems that will illuminate the entire room with one bulb. It is also used for bringing sunlight into the interior buildings. Fiber optics may be also used in surgeries. One fiber to look what is inside another fiber that can be used to pinpoint laser pulse to be a bad section of the tissue. Thanks.